planning and implementing failover clustering. And now for something completely different. Maybe not completely different. I don't know. We've talked about clustering so far, and if you're following along with this exam in the proper order, then you've probably implemented clustering already. But this nugget is more about sort of why you would make the decisions you would make with clustering. I think you already understand that clustering requires shared storage in Windows Server, and that it generally requires, if not highly, highly, highly suggests, having a separate networking. But in this nugget, we want to talk about some of the decisions you will make in when you put together failover clustering, when you implement it. Well, why would you do it, and for what reasons? And as you can see here, we're going to talk about not only multi-node clustering, but also the concept is multi-site clustering, which in the past has been a fairly challenging thing. Back in '08, I believe it was '08 R2, things got a little bit simpler with multi-site clustering. One of the big pieces being the elimination of all the nodes being on the same subnet. And if you can think about that, when you've got a distributed subnet across multiple geographic locations, well, that's a very difficult thing to do sometimes in the networking world. Here in this nugget, we'll talk just a bit about multi-site clustering. I also want to kind of just step through all of the design considerations that you'll need to be aware of whenever you're implementing your cluster. I made a joke earlier on in this series. I said, back in the day, in the earliest days of Windows clustering, for some reason I became the guy that was doing Windows clustering and knew the most about it. And the quote of the day had been, as the corporate expert in Windows clustering, I recommend you never use Windows clustering. That's because back in the earliest days of Windows clustering, it was a high availability solution, which for some reason would always reduce the availability of the servers that we had. Anytime we implemented it, it's like things went down more often. Well, things have changed quite a bit these days, and Windows failover clustering has improved dramatically in '08, again in '08 R2, and particularly now in Server 2012. One of the big changes here is the embrace of cluster shared volumes. We saw that back in '08 R2 with CSV as it relates to Hyper-V. Well, CSV now does some of the same things, or brings some of the same improvements that it brought for Hyper-V to many of the other roles. I would be firmly cognizant of what CSV's capabilities are now in Server 2012. I'd understand when you would implement it, and why you would implement it, and the fact that it just exists and it's a nice thing. Back in the prior to CSV, if I had a LUN and I had a bunch of roles that were sitting on that LUN, if I needed to fail over one of the roles, well, I had to fail over the entire LUN to some other node. Well, CSV gives me the ability to not fail the entire LUN. It can give me the ability just to fail the individual piece over, or the individual role over to the additional nodes. So CSVs make things incredibly more granular than were they in previous versions, and that's a really, really good thing. Now, the third one down here is one that I moved over from planning and implementing highly available server roles. Here in the clustering sort of subsection of this series, you're going to see a bunch of stuff that got moved around just because it just made more sense for us to talk about that here. Okay, and what this is essentially the recognition that there are these generic application scripts and services roles that you can add to a cluster. That they're there, you can use them. You really shouldn't use them unless you have some solution that has generally been pre-packaged in order to use them for one reason or another. So they're there, but you won't really find yourself using them too terribly much the moment that you finish passing your MCSE exams. So let's take the world, however, and kind of cut it in half before we get into the click-by-click. And let's talk here about the multi-node. So this is the multi-node side of the equation, and this is the multi-site side of the equation. And I bring this up because, well, there are different decisions you will make depending on what you need to do, and you'll choose one of these over the other based off of what the requirements that have been laid upon you. Now, over here on multi-site clustering is sort of a superset of multi-node clustering, and the fact that you can take a multi-node cluster and then extend it to a second site if you want, and also the things you have to be aware of, like the DNS settings, the quorum configuration. You've got to worry about split brain, site-to-site split brain. All of these architectural decisions that you have to make become much more evident when you start moving into the multi-site world. So, all right, let's start with multi-node just because it's simple. In the multi-node world, I am not going to give you 2, I will do 4 nodes just because everybody always seems to want to do 2 nodes in clustering, and it's almost like it's too simple. So let's say I have a cluster out of 4 nodes, and in multi-node clustering, I have a piece of shared storage that is literally shared across all 4 of these nodes. Back in the day, this was something that was incredibly exciting because NTFS, well, forever has not been a cluster-aware operating system. In the multi-node world, all of these hosts exist in a single site, and generally in the same subnet, although they don't technically have to anymore. And when I have some sort of role that exists on one of the hosts, I can then migrate that role over to another node here in the cluster, or really anywhere here in the cluster, because that's what a cluster is designed to do. So in the multi-node world, comparatively, the multi-node configuration is going to be far simpler than the multi-site configuration, because you have all of these nice happy nodes that exist in the same, usually same subnet, same LAN, that provide for failover and resource load balancing across all the different hosts that exist in that cluster. Well, things get quite a bit more challenging when you start moving into the multi-site configuration. So in the multi-site configuration, let's say that I've got my a original connection here. So here are my 4 hosts in site 1, right? And then because of some requirement, I have a need to put an additional, let's do 3 nodes over here in site 2. So this second site, my backup site, my disaster recovery site, whatever you want to call it here. This secondary site now contains more hosts, more cluster hosts that are all designed to sort of interact with each other over between these 2 sites, right? Got a lot of decisions we have to make here. Number 1 is, in order to implement multi-site clustering, one of the things that we do have to have, and that Microsoft does not support, does not build software for, does not have any kind of technology that can accomplish this. Don't get wooed by things like DFS. Don't get wooed by any of the replication technologies that you may hear out of Microsoft. If you want to do a multi-site cluster, you need to have some technology that takes the data from this side and shoots it over here to this side using one mechanism or another. Okay, so some sort of replication solution. Now, there are 2 options for that. There is synchronous and asynchronous. CRONOUS, although I think there's an H in there somewhere. These synchronous or asynchronous replication technologies are there to support taking a piece of data and moving it over here, and a piece of data and moving it over here. So bidirectional, synchronous or asynchronous replication. That's what you have to have in order to support this. Now, the important difference here between synchronous replication and asynchronous replication is what has to transpire for a 0 to turn to a 1 on this side, and then for it to be, for the transaction to complete over on this side. In a synchronous replication tends to happen in a way that the acknowledgement has to occur before the next bit of data is allowed to be stored on the source disk. Okay, so let's assume this is the source disk. Some server has turned a 0 to a 1 over here. Right, well, when that 0 turns to a 1, well, then I have to notify my secondary over here that the 0 has turned to 1, and this secondary then needs to have whatever resources are available to flip that bit, and then notify back to the original via some acknowledgement that the bit has been flipped. As you can imagine, wow, that puts a pretty big sort of hold on making changes here into these disks, because I have to ship the change over to the other side and then wait for the acknowledgement to come back before I make the next change. And that can have a real effect on performance. So the reason why we do that, however, is because synchronous clustering ensures that the data is equivalent across both nodes before the next change occurs. Synchronous tends to be short distance clustering. But it's also maybe not more secure, it's more resiliency. So increased resiliency, because I know that I'm not going to do anything over here until I do something over here. Now contrast this with asynchronous, which is exactly the opposite of that. With asynchronous, I batch up a bunch of changes and send them over in the hopes that they'll get over there. Right? There is no delay for an acknowledgement to occur in asynchronous clustering. Asynchronous tends to be of longer distance. And when I say distance here, I mean geographic distance. Typically, in a synchronous transmission scenario here, your distance between these are measured in feet and not miles. Okay, it can be a large number of feet, thousands of feet, but it's typically not in miles, just because the amount of time it takes as you stretch those clusters apart really, it just reduces the performance, because I got to make that bit of data transfer from one side to the other. The other piece I have to be careful about, and this is something that changed in, and again, I don't remember if it was 08 or R2, but prior to those days, the entire cluster across both sites needed to be in the same IP subnet. Well, that's not the case anymore. This can be the 192.168.1.0/24 net, and this can be the 192.168-2.0/X subnet over here. This is both awesome and somewhat challenging at the same time, because if I end up taking a resource from here and it moves over to here, well, I don't have to change the IP address. But if something happens and I have to move the resource over to there, well, I have to rewrite the IP address to the new addressing scheme before that resource will actually work on the other side. So while multi-site clustering in 12 can actually support going across subnets, well, it actually almost creates a problem while it solves another problem. You will have to be aware of that, and you'll have to do most of the rewrite yourself in order to support that. The last thing, and this is something that I think a lot of people really forget about, is in a multi-node cluster over here, you have there are really 4 different types of quorum configuration in multi-node. You already learned about these back in those previous exams. And very generically, they are, I only care about the storage, that's number 1. I only care about the hosts, which is number 2. I care about the hosts and the storage, which is number 3. And I care about all of this plus some offline file share out here, so some file share, which is number 4. In reality, although those are the 4 different types of cluster quorum configurations that exist, you can kind of break them down into 2. Okay? In quorum configuration number 1, I care about the nodes. And in quorum configuration number 2, I care about the nodes plus something else. Okay? That something else can be shared storage. That something else can be a separate file share. All right? So those are kind of the 2 different halves. As you can imagine, you may be asking yourself, okay, why in the world did Microsoft create 4 different quorum configurations for clustering? That just seems radically, massively complicated when it seems almost unnecessary. But let's think about this. On this side, I have a 4-node cluster, and on this side, I have a 3-node cluster over here. In a 4-node cluster, if I lose 2 of the nodes, right? So let's say that these 2 nodes are somehow separated. They may still be together in some little micro network. Who knows, the segmentation that occurs in your network, right? If I lose 2 of those nodes, and I only care about the nodes, well then which of these 2 halves is the real cluster, and which of these 2 halves is the failed part of the cluster? Right? You don't know. I mean, you do know because you're the admin, but from a logical, I can code this into the cluster perspective, it becomes very difficult. So in an even number of nodes scenario, we typically want to use the nodes plus something else. So either nodes plus the storage, the shared storage, or nodes plus the file share scenario. Because in that case, if this isolation happens for these 2 nodes, well, there's 1, 2, 3 votes that still remain, and we now know that this is the correct part of the cluster. This is the actual cluster, and these are the bits that have actually isolated. Now, in the odd number of nodes scenario, in that scenario, we can simplify things because, well, all right, in 3 nodes, if I lose one of them, I still have 2 left. Or if I have 5 nodes, I can lose 2 of them and still have 3 left. So I'm never going to get a tie number of votes. So that's sort of, use that as your mnemonic for remembering when Windows clustering automatically chooses a quorum model, this odd versus even is the way that it does it. And then you can override that if you want. I'll show you where that is done here in just a second. But these are all the decisions you'll make in choosing what sort of quorum structure you will have. Now, things get somewhat more complicated over here in the multi-site world. Right, so I have technically 7 nodes in this cluster. But now, do I use the nodes? Or do I use the nodes plus something else quorum model? What do you think? Would you choose nodes, or would you choose nodes plus something else? Well, things get quite a bit more difficult because I no longer have to. I'm in addition to having to worry about the loss of a single node in this world, I also have to worry about the loss of a complete site. Right? So some backhoe cuts the cables for my backup site here. Well, if they cut the cables for the backup site, which of these 2 pieces is actually still the correct cluster? Inside this cluster, it believes it actually is still a cluster, but I've just cut the network cables between this and this side of the cluster. Wow, this gets really complicated here, right? Because if I were using the, let's switch things and say that the cables got cut over here. If I were using the nodes plus something else, well, it's entirely possible that this could be cut and this would still believe itself to be a cluster. So again, there's a lot of real significant challenge here when using multi-site. The best practice, although it is something that is very difficult to do because not a lot of us have this, enjoy this, but the best practice in a multi-site cluster is to actually, in a third site, a site that is neither the first site or the second site, is to put a file share in that third site and make that the something else that is used by the cluster. So if this is Denver and this is Las Vegas, well, this becomes Omaha. And that is really the best practice because that third site becomes the witness site between the other 2 and ensures that everybody plays fair in the case of an entire site loss. So I know this is sort of an extended introduction to the design of clustering, but I think all of this is necessary because it highlights that clustering is something that should not be taken lightly. Right? You just don't start creating nodes, particularly as you start going past your basic 2-node cluster, and just throwing things up because, well, you've got more decisions that you have to make than just where those nodes are. As we move into multi-site clustering, the complexity gets even more challenging. So let's spend a minute now. In fact, let me just bring this back up here. Let's spend a minute now talking about, on this side, okay, with all the architecture piece in place, right? Let's talk about the individual settings and why you would make those settings. And then from there, let's talk about how you can create a generic application and work with one. So I want to go through and just kind of highlight the major settings here in clustering. As you'll see here, I have a 2-node cluster that I have 3 networks on. I have my cluster private network, I have a production network, and then I have a storage network here. And I've set these up just as I explained before. So just to draw things to make things easy, here is my cluster host here, and I have one for production, I have one for cluster private, and I have one for storage. And I've removed the teaming in this sense, in this case, because the teaming just makes things more complicated. But the idea here is that I've segregated out these 3 networks because this is what my cluster wants. It wants to have a separate production than a cluster private net. It wants to have a separate storage than the other 2 as well. And when you do that, it becomes very important for you to identify for each of these, which decisions do you make? Right? So I want the cluster network communication to exist on that network, and I want clients to connect through the network as well. I want my outlet clients to talk to Exchange using this connection, and I want the cluster to use its heartbeat on that connection as well. Now you might be asking yourself, well, wait a minute, why in the world would I do that? I'm doing that because the cluster private network is it's essentially the primary mechanism for the cluster to communicate, and I have the production net as a secondary mechanism, or either that or vice versa. So I have two routes in which the cluster heartbeat can go across to ensure that if I lose any of the routes, I still am going to have that cluster successfully. Now you'll notice down here under the storage network that I've got that set up so that I'm not allowing the cluster communication to occur. I don't want to impact any of my storage connections here. So these, again, just make sure that when you're building that cluster, you've set up those networks appropriately. When you build the cluster as well, down here under the cluster properties, there are a variety of resource types, obviously, and the permissions that you can do here. But one of the most forgotten little links is the core cluster resource group here. If you played with clustering back in the old days, this is something that was exposed over here in the roles, but now it's sort of hidden under this properties screen. And what this allows you to do is identify just where you want this resource to go. Okay, do you have preferred owners for the cluster group, or do you not? You'll see that there aren't any here because you don't want the resource group to be preferred by one versus the other. And then what are also the failover settings here for the cluster resource group? For the most part, you can kind of leave these the same. It becomes more important as you start moving into multi-site clustering that you start making sure that your cluster group is always in your primary site. Okay, you want it to fail over the primary site and then only fail over to the secondary site whenever you have a site loss. So that's our cluster group. Let's take a look also at the storage over here. Let me click over here on the disks. You see I have one disk here. This is the disk that's being used as the quorum disk. And if I take a look at properties here, we can take a look at, you'll notice that I've created an extremely large quorum disk here of a terabyte size. I got a little crazy with creating disks the other day. Some dependencies here if you want to add dependencies for failover. Okay, so do you want this to fail over if something else fails over? I want to focus here on policies and advanced policies here for just a second. So for these disks, the policies determine what you do if the resource fails. Do you want to not restart it or restart it on the current node? And you want to at least give it a try here on this current node before you fail it over to somewhere else. So you can see here that, okay, there's 15 minutes, maximum number of restarts and the number of delays. And if the restart is unsuccessful, well, fail over all the resources in this role. And if all the restart attempts fails, then begin restarting again after a specified period. So the one thing I tell people with clustering is that this is a solution that is always prepared for failure. It's like that friend of yours that you just really go and you really hate going to have a beer with because all they talk about is how their life is not really exciting. But the point of a cluster is to be prepared for failure. It is a doomsday prepper, as it were. And so all of these settings are here to help you figure out in all of the possible failure conditions what you should do. So generally these are okay to set, although you might tune them for your specific requirements, and you might also tune how often the cluster checks its resources. So in a basic check versus a thorough check. Okay, and there are standard time periods or user-defined time periods for how those work. And also for the disks, who do you want your possible owners to be? Do you want to remove certain owners from being owners of this disk? Okay, you can do that here as well. So you may do that if you want to ensure that certain owners are only processing certain items. They're not going to be responsible for disk resources. Okay, these are the storage placement items and really also the heartbeat items, as it were. I do want to show you also the quorum configuration, although admittedly the quorum configuration's gotten quite a bit better in this version because Microsoft has essentially, well, they've taken a lot of the quorum decisions away from you. You'll notice here that the typical settings determines quorum management options automatically and will select the witness automatically. Or you can choose to add or change the quorum witness or use an advanced quorum configuration, which gives you more options. So in the advanced configuration, you can determine which nodes will not have a vote to figure out who has quorum. Okay, in a multi-node cluster, you don't really do this that often. In a multi-site cluster, again, you can do this to protect yourself from resources failing all the way over to the other site whenever you don't want them to. That is the most important configuration. In fact, let me just to make sure that this is completely understood, let me just kind of highlight that problem and why this becomes very important. So here's site 1. Here's site 2. Okay, and I have my 2-node cluster here, and I have a 2-node cluster here. The most important thing that you have to prepare for in a multi-site configuration is the fact that, all right, well, I have a resource that sits here, okay, and this resource needs to fail over because something's going wrong with this host. Generally, you'd want to configure the possible owners. You want to configure the things we were just taking a look at before with the configuration. You want to configure the preferred owners and all of these settings so that the failover happens to the local site in every case, except for when you have an entire site failure, and then the failover occurs to the secondary site. You can modify your preferred owners, you can modify your possible owners, and you can adjust your quorum configuration to support this. Go here within the site first and only fail over to the other site in the case where you have a really bad day and the entire site goes down. That's really what you're trying to protect yourself here with these configurations. So I can choose here what nodes are available. I can let the cluster dynamically adjust its quorum model. This setting is so incredibly important here in Windows Server 2012, especially in the situation where you add additional cluster nodes one at a time. Remember how I told you there's an odd and an even model? The odd model was involved using a piece of storage to something else, and the even model was just the hosts, or vice versa, actually. So when you're adding in new hosts one at a time, you are changing things from an odd to an even model. That's why Microsoft now allows the cluster to dynamically manage the assignment of node votes. It just keeps things simple for you as you're adding hosts down the road. The other item, and really this is the only other item I want to show you, is whether or not you're going to use a shared storage witness or a file share witness. And these are essentially the same thing. I believe there's more data. The actual cluster database gets stored on the disk witness, whereas it doesn't on the share witness. But you can choose either of these. The file share witness, again, tends to be in multi-site environments, but you can really put it anywhere. Okay, so whatever you want to do there. But that's essentially the options that you have here for your cluster quorum. The only thing that's left here is if you choose the disk, which disk do you want to choose? So again, these are all the decisions that are important to make whenever you're dealing with a cluster, because people get really kind of overawed with clustering before they realize, wow, if I don't do things correctly in the beginning, well, I can really screw up things down the road, and I won't actually know that something has gone wrong until the failure occurs. It's almost the worst part of clustering, is you never really know if you've got everything set up correctly until something bad happens, and you'll see how well it protected you from that something bad. So I had one of those items that was moved from one of the other objective domains, and that was for implementing highly available applications. And you have kind of already done this, I think. If you have not, I will show you very basically that the roles that a cluster can support, a little bit smaller than they used to be. There used to be more roles here. But in and amongst these roles are the generic application, generic script, and generic service roles that you can make highly available. And the whole idea here is that there are certain application scripts and services that you want to make highly available. You just don't do this for whatever applications that are out there. You generally do these with applications that are designed to be clustered. But you can actually, the cluster service here will allow you to make highly available any application. In fact, humorously, let's actually make a sort of a somewhat odd application highly available. Let's make Notepad a highly available application. Now, you would never do this in production because Notepad is not something that you're connecting to remotely. but you can because Notepad is an executable, and so hence it is an application. So if I choose Notepad here, I've got to give the clustered edition of Notepad a role, or excuse me, a NetBIOS name. We'll call it cluster Notepad. And then I've got to give a piece of storage here. Now, before I can actually create these resources, right, I have to have that storage available so that there's some place to actually store the contents that correspond to this activity. You'll notice here that I haven't actually made any storage available. So what I need to do is actually, before I create this highly available Notepad, I need to make sure that I have some disks. Well, wait a minute. I thought I had a disk. I had a whole terabyte here disk that I created for the quorum. Aha, now you're seeing one of the problems that can occur when you allow Windows to automatically determine what the quorum drive is going to be. So I sort of purposely created this drive as a terabyte in size to show you that, right, well, when a disk gets defined as the quorum drive, it becomes very difficult to use it for much of anything else. The quorum drive really needs to be very small, very, very small, in fact. In addition to that quorum drive, we need additional disks that we'll use to support all these other roles that we end up adding in. Now, let me click the Add Disk button here. I've already connected up to this machine some storage. Right? It's connected up to both sides of the cluster. So because it's connected and it can be seen by all nodes in the cluster, well, it's become available as an available disk. And if I add it here into the cluster, poof, I now have cluster disk 2. Once I add it into the cluster, right, that makes it available as storage, and I can install roles onto it. If I take this cluster disk 2 as available storage, I can also add it to cluster shared volumes as well. I told you just a minute ago that cluster shared volumes are supportable now for more than just Hyper-V. I can do things like file services, for example. And adding things to cluster shared volumes is nice because I can fail over granularly each individual object as opposed to the entire disk resource all at once. So let's actually add this to cluster shared volumes. Now, what's interesting about a CSV, right? If I create this as a CSV, first and foremost, we change the location of it down here to C drive. But even though CSVs are supported for a bunch of new roles, they're not actually supported for all new roles. Right, so I choose Next here, and we try to create our new application again, Notepad here, and then our cluster Notepad client access point, and choose Next. And wait a minute, there's no storage available. I was thinking I'd be able to use CSV with this generic application settings. Well, here's where you can begin to get fairly confused as to where CSV becomes important. CSV supports a larger number of roles, but it doesn't support all the roles still today. So in order to create that generic application, I need to remove it from from being a CSV and make it just a piece of available storage. And as available storage, now for the third and final time, I can create that generic application, call it cluster Notepad, and I now can associate that with the disk that's created. So I would be very conscious of which of the roles CSVs support. If you're working with files, if you're working with Hyper-V, if you're working with SQL databases, if you're working with any of those supportable roles, you absolutely want to use CSV. But if you're using any of these generic things, it's something that's not going to be supported. Do I have any registry data locations with this application that I want? Maybe I've got here in, if I go to regedit, maybe I've got here in there's a Notepad location. Gosh, HQ Local Machine Software Microsoft Notepad contains some registry information that I want to populate around with this Notepad. So Software Microsoft Notepad will be the registry location that I will add. And then, okay, well, I'm ready to create this thing next, and the application gets created. Creating that application takes a minute or two. Okay, once it's available, then I can fail it over and do all the things that I'm used to thinking of with these clustered roles. There are, in addition to generic applications, there are two other roles that are at least worth looking at here, and that are the generic script and the generic service. And I'm not going to go through the entirety of this, but just be aware that instead of pointing to an application, you're going to point to a script. In this case, for a generic script, and instead of an application, you're going to point to one of the services that exists on all the on all the cluster nodes. So these are essentially all the things you have to be aware of here for these generic resources. But I'll tell you, this is another one of those great situations where you need to learn about this for the exam, but you probably will not be creating too many of these generic resources all that often. I want to click back here one time, and just to, again, sort of solidify in your mind the notion of possible owners and preferred owners. Okay, the preferred owners are the owners that you prefer this resource to exist on. Okay, if it can, it will exist on cluster 1 as the preferred owner, or perhaps in the other direction. These are the most preferred at the top, the least preferred on the bottom. Okay, so just be aware that you're going to want to set these so that you can do your own load balancing in and amongst these resources. And then over here on failover, you can identify how many times that the service, or in this case the application, is going to fail before it just gets left in the failed state. The idea here is that sometimes you have an application that it just keeps failing. It's failing, it's failing, it's failing, it's failing. In the old days, I used to call this cluster bounce. Right? And I'm unaware if that's actually a technical term, but you would have a resource that would just sort of bounce around between the different nodes in your cluster until it would go bounce, 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 then fail entirely. Well, you want to try to protect yourself from these, because if you have a resource that is failing a whole lot over a short period of time, well, there's probably something bigger going on that you need to resolve. So the values for these are set relatively low, so that if there's more than one failure that occurs in every 6 hours, you know what, let's not actually keep this highly available. Let's not create a bounce condition. Let's let it fail and then fix it. The other one here is failback. And failback is one of those, especially the immediate failback, that can really, I don't know, I've had this burn me more often than anything else. Because failback says, you know what, if you fail over because of one condition and that condition no longer exists, well then go ahead and fail me back to where I was. Right? Fail me back to my preferred owner again. But the problem is when I have a problem with one of these resources, a lot of times that problem kind of waffles. So it'll happen, then it won't happen, then it'll happen, then it won't happen. And with the immediate failback, what you end up is another sort of bounce condition where as it's happening and not happening, you're failing it over back and forth until eventually it just fails entirely. So I tend to suggest, and this is not necessarily Microsoft's recommendation, but it is the default recommendation, to be very careful with turning on failback. And if you do turn it on failback, you might want to set it up not to fail back immediately, because you always want to try to protect yourself from that bounce condition. It really creates for a bad day, especially if you've been touting how highly available your services will be by adding them into a failover cluster. So what have we talked about this nugget? We've talked about really a variety of topics here in failover clustering. Talked at a very high level about all the different things you have to be conscious of when you're doing multi-node, and then the much greater set of things in multi-site clustering. And then we went through all these variety of configurations in clustering, networks and network priority settings and failover and heartbeat and all the DNS settings and stuff, and making you aware that, gosh, you've got to do a lot of planning before you ever get to implementing that failover cluster. And then we spent a little bit of time here with this one moved topic that talks about generic application, script, and services and how you would set them up here on the cluster that you've just created. Coming up next, we're going to shift for just a couple of nuggets away from failover clustering, but we will come back to it. The next objective domain talks about planning and implementing highly available network services. And this is Microsoft speak for an NLB cluster. You need to be aware of what the differences are between a failover cluster and an NLB cluster, because they are not the same thing in any way, shape, or form. And I will help you understand what those differences are if you're not already cognizant of them. I'll show you how to build an NLB cluster and how to, or when you would implement NLB as opposed to when you would implement regular traditional failover clustering. That's the topic for our next nugget. So until then, I hope this has been informative for you, and I'd like to thank you for viewing.